Okay, and the second terminologies that you need to know is diagonal matrix. What is diagonal matrix? So if you have ever played chess before, diagonal means if you ever played chess before, you remember how a bishop moves? The bishop, okay, bishop is the one that is right beside of the knight, right? Okay, it moves diagonally. It moves diagonally. This is what we call diagonal. It's like, can imagine like from the corner to another corner. Can imagine like that. That is what we call a diagonal. So in terms of matrix, diagonal matrix is like the main thing we are concerned about is the one that are in from the left top to the one that is a right bottom. This is what we call the leading diagonal. Okay, we're talking about the 3x3 matrix. 3x3 matrix. This is a 3x3 matrix. So diagonal matrix refers to the one that is in this. They are all have a certain number lah. Okay, have a certain number. And whereas for those that are not in this diagonal, they are all 0. They are all 0. This is what we call the leading diagonal. This is the leading diagonal. Except for this numbers in the leading diagonal from the top left to the one that is right on the bottom. Okay, all the numbers outside of this leading diagonal, they are all 0. This is what we call a diagonal matrix. So for example 1, 10, -3, and the rest are all 0. So as you can see here, the leading diagonal, they are all filled up with other numbers except for 0, and the rest, they are not in the leading diagonal, they are all 0. So this is what we call diagonal matrices. Okay, and the third terminology that you need to know, which is identity matrix. Identity matrix. Okay, identity matrix, you should be quite familiar with this lah, as you have learned this in your SPM as well. Identity matrix is basically, okay, for example, last time you learned about the 2x2 matrix. Identity is like this: 1, 0, 0, 1. So what is an identity matrix? Identity matrix is like you can imagine like the whole leading diagonal, right? Leading diagonal, they are all filled up with the number 1, and except for the leading diagonal, like outside of the leading diagonal, they are all 0. So if you are talking about 3x3 matrix, then the identity will be or the leading diagonal will be 1, 1, 1, and the rest will be 0, 0, 0, 0, 0, 0. So this is what we call identity matrix. Only the leading diagonal with the number 1 and the rest are all 0. So this is what we call identity matrix. What if it's a 4x4 matrix? I mean, we don't learn about this lah in SDPM, but the concept is the same. The leading diagonal will still be 1, but now you got 4 rows and 4 columns lah. The rest will be 0. So this is what we call identity matrix. The leading diagonal all filled up with number 1. The rest, they are all 0. They are all 0. This is what we call identity matrix. And it's usually denoted by the letter I lah. Identity matrix. I refers to identity. Okay, the next one, what we call the upper triangular, and also the lower triangular. Okay, I'm gonna erase this. Lower triangular matrix. Okay, upper triangular is like, you can just imagine like there's a triangle on the, okay, let me just draw a 3x3 matrix first. So for example, 1, 5, 7, 0, 2, 8, 0, 0, 3. Okay, upper triangular matrix is like except for the leading diagonal, okay, wait, below the leading diagonal, they are all 0. Can you see? Below the leading diagonal, they are all 0. Like upper triangular means the upper triangular part all have number one. All got number. This upper triangular here, they are all filled up with numbers. And whereas, except for this upper triangular, all the numbers, they are all 0. The rest are all 0. Means the main diagonal, okay, this is the diagonal, and above of it, they are all filled up with other numbers. They are all filled up with other numbers. This is what we call upper triangular. And the rest of it, they are not in this red box, they are all 0. This is what we call upper triangular. And then lower triangular means like this. All this in the lower triangular, they have a certain number. And those that are not in the red box is 0. The rest are all 0. This is what we call lower triangular matrix. Means the one at the lower triangular, they are all filled up with other numbers, and the rest, they are all 0. So we are always looking at this side, like the leading coefficient, the leading diagonal is always here. Leading diagonal always here. And then we look at this lower triangular. And the upper triangular is here. Means the rest, they are not in the red box, they are all 0s. The entries are 0s. Okay. And next one. Symmetric matrix. Symmetric matrix is like symmetrical about the leading diagonal. For example, talking about 3x3 matrix, there will be a leading diagonal. I give a very random numbers like 3, 0, and 4. And the symmetric matrix is like they are symmetrical about, okay, just imagine like this is like a mirror. Imagine like this is like a mirror, and this one will reflect at here, and this number here will reflect at here, like the furthest with the furthest, and the one here with here, and here and here. So now the numbers here will be the same as here. Number here will be the same as here, and this one will be the same as this one. So if this is 2, then this must be 2. If this is a symmetric matrix. If this is 5, then this must be 5. If this is x, then this must be x also. So this is what we call a symmetric matrix. They are symmetrical about here, leading diagonal. This is what we call a symmetric matrix. The entries are symmetrical about the leading diagonal. This is the leading diagonal. Okay, and the last one. Transpose of a matrix. So transpose of a matrix is very simple. Basically, like, for example, I give you okay lah, should I write? I'll write it in a general way lah. For example, the matrix A, this is A11, A12, A13, A21, A22, A23, A31, A32, A33. Transpose of a matrix is basically you write the row as a column and you write the column as a row. Means you change all the originally the first row now becomes the first column of the new matrix. Basically, if A is like this, right, then the transpose of A, we write it as A T, and the T looks like a superscript, like A to the power of T. This is how we write it. Okay, A T. So AT refers to transpose of matrix A. Transpose of matrix A means we write the whole row here, the first row, as the first column of the transpose. So originally this is your first row, right? Now we write it like this: A11, A12, A13. Second row will become the second column: A21, A22, A23. And the last one, the third row, will become the third column: A31, A32, A33. Means I write the row as columns, or you can imagine like write the column as row, they are the same thing. Okay, so for example, if the matrix B is given to be 3, 1, 2, 0, 5, 6 and 7, 4, 9, then the transpose of matrix B will be write the row as column. So 3, 1, 2, which is the first row, will become the first column: 3, 1, 2. The second row will become 0, 5, 6, second column. Third row will become the third column: 7, 4, 9. So this is what we call transpose. I write the row as the column. I change the whole thing to become column. Okay. So will there be a case where if you write out the transpose and it still looks exactly the same as before? And this is what we call when it's symmetric matrix, right? If a matrix is symmetrical, symmetric matrix, your transpose will look exactly like how it looked like before. So for example, if B is 1, 4, 7, this is let's say symmetric matrix, right? Means you'll be symmetrical about leading diagonal, right? Means if here is 5, then here must be 5. If here is 7, here must be 7. If here is 8, here must be 8. So if you see, if I were to write it in the transpose, first row become first column: 1, 5, 7. Second row will become second column. Third row will become third column. And you see, if you are a symmetric matrix, your transpose will look exactly the same as the one that is the original matrix. So if B is symmetric, then the matrix B will be the same as the transpose of a matrix B. So you must know this property lah. If they say, oh, they are symmetric, then you must know the transpose will look exactly the same like the one before. So only if they are symmetrical, okay, at the leading diagonal. This is what we call the symmetric matrix. You must know this. Usually they will use this on, like, they give you unknown and then they want you to find out the unknown lah. But then they never tell you. Okay, they will tell you the transpose is the same as the original one, and then you must know it's a symmetric matrix or the vice versa. Okay, it depends. We will look at question and we will solve it. Okay. And next we'll talk about equality of matrix. So equality of matrix. Okay, equality of matrix. Basically, you must know what is equality of matrix is like. It's like comparison. For example, like x, y equals to 3, negative 5. If and only if x is equals to 3 and y is equals to negative 5. You must know two matrices are only equal if and only if they have the same order. If they don't have the same order, then obviously they are not like, you cannot say that, oh, x, y, z and then like 5, 2. How can you compare? You can't compare because they are different order. So x equals to what? You don't know. Y equals to what? You also don't know. Z equals to what? You don't know also. You must know the equality of matrix can only be applied when it's at the same order. For example, this is a 2 by 1. This is also a 2 by 1. Then I can say that x is equal to 3 and y is equal to negative 5. So, for example, 1p4q50 is equals to 1 negative 3r25s. So if you see, if we were to compare, we can say that here p is equivalent as negative 3. We can say that p is negative 3. And we can also see that 4 will be equivalent as r. So r is equals to 4. And what else? Q and 2. Q is equals to 2. And also S is equivalent as 0. So this is the equality of matrix. And on this you can do like some operation on matrix, like for example addition and subtraction. But those are the things that you already know how to do lah. So it's very simple. For example, A is equals to 2 negative 1 3 1 2 4 0 1 2. And then B is 1 0 2 3 negative 1 0 and 2 1 4. If I say A plus B means use the A to plus the B. Use the matrix A to plus the matrix B. So how would you do this? It's very simple. You need to make sure before you do any addition or subtraction, right? You have to make sure first thing is they are in the same order. This is a 3 by 3 matrix. It must only do addition and subtraction with another 3 by 3 matrix. If it's a 3 by 2 or whatever, 3 by 1 or 2 by 1 or whatever, you can't carry out the addition or subtraction. Okay, it has to be the same order first. So you make sure they are both in the same order already, then you can do the addition. So A plus B means the first row add up with the first row of B. The first row of A add up with the first row of B. Means 2 plus 1 on the first row. This one, second row, negative 1 plus 0. Negative 1 plus 0. And the third one, 3 plus 2. Okay, and then so on. You just compare the position. 1 and 3, 2 and negative 1, and so on. So 1 plus 3, 2 plus negative 1, 4 plus 0, 0 plus 2, 1 plus 1, 2 plus 4. So final answer A plus B is equals to 3, negative 1, 5, 4, 1, 4, 2, 2, 6. So this is what A plus B gives you. You must make sure that they are all in the same order first before you add up or you do subtraction. If subtraction, then the order matters. A minus B is not the same as B minus A, obviously, but A plus B will be the same as B plus A because addition. The sequence doesn't really matter because it's addition. But if you are subtracting, then you must make sure that the order is correct. The sequence must be there. A minus B is not the same as B minus A. And next, multiplication with a scalar. Multiplication of a matrix by a scalar is like the product of a scalar k. For example, a product of a scalar k and a matrix A. For example, if I say A is I just give random numbers lah. So if I multiply the whole matrix by a scalar, then scalar means just a constant lah, like a constant Ka, then what you will get would be all the entries, all the numbers in the matrix, they are all multiplied by the constant K, and you get 2K, 3K, 5K, 4K, 6K, 7K, negative 10K, 4K, 7K. So it all depends on what is the value of the K. If it's 5, then everything here multiplied by 5, 5, 5. If it's 7, multiplied by 7, 7, 7. Just like that. Just multiply the whole entry by a constant. If you multiply the matrix by a constant,